In the last video, Multiple Regression 3, we looked at the process macro for the first time, and we talked about how we can use the process macro to do a simple slopes analysis when we're testing for an interaction between two continuous variables. Now, before that, in Multiple Regression 2, we looked at interactions between categorical and continuous variables. So what we're going to do in this video is we're actually going to look and see how we can use process to do the same things that we did 2 weeks ago. So we're going to redo two of the problems that we did previously, but instead of doing them the way that we learned to do 2 weeks ago, we're going to learn how to do them in process and see how process gets us the same results, but a heck of a lot faster and easier. So think back to 2 weeks ago. One of the first problems we looked at, in fact, the first problem we looked at to test an interaction in a regression, had to do with signature size and narcissism. So the goal here was to see, A, does signature size predict narcissism? And B, does this relationship depend on whether a person is a man or a woman? So your X variable is signature size, your outcome is narcissism, and your moderator variable W is sex. And when we ran this study, what we found was that there was a relationship between signature size and narcissism, but only for women, not for men. And the way we figured that out is that we ran the regression, we then split the file, we ran separate regressions for men and women, and compared the results between men and women. We can actually run that same analysis using the process macro that we started talking about in the so we would run this analysis. Sorry, let me jump back for a second here. I should mention in the options menu, we're going to do all the things that we would normally do. So we could we should request mean centering. We could request a graph like we saw how to do last week. We would do all the stuff we would normally do in the options menu before we run this analysis. So here is the output from process if we were to do this same problem using process as opposed to the way that we did it 2 weeks ago. And as we saw 2 weeks ago, there is a significant interaction. We could look at the t-test or we could look at the f-change test. Either way, we're going to see that the p-value is 0.004, telling us that the relationship between signature size and narcissism depends on sex. Now, instead of getting a traditional simple slopes analysis, what process does for us is it automatically splits the file, and it gives us one test for just men and one test for just women. So the tricky thing here is we have to make sure we know how this variable is coded, right? So 0 in this case is male, 1 in this case is female. So for men, sex equals 0, there was not a significant relationship between signature size and narcissism, but for women, there was a significant positive relationship between signature size and narcissism. Women with larger signatures tended to have higher levels of narcissism. So this is the same pattern that we saw when we did this the long way 2 weeks ago, where we did the dummy coding with syntax and we computed the interaction term manually. That took a lot more steps. Process, we just throw everything in and it does everything for us. So this is usually the point of the semester where everybody gets mad at me that I made you do it the long way first before showing you this little shortcut, which is understandable. But this way you at least know what process is actually doing when it's doing all this stuff. It's mean centering for us, it's dummy coding for us, it's splitting the file for us. All those steps that we used to have to do individually, now thanks to process, we can ask process to do them all at once. And it's very, very simple and very fast. So again, same example, different process, same result. We see a relationship between signature size and narcissism for women, but not for men. Last thing I want to mention about the dummy coding here. Whichever of the two groups is coded as a lower number will automatically get dummy coded as the control group. So I think in this particular file, male was originally coded as 1 and female was coded as 2. Since male is the lower number, process just takes male and makes it 0 and then bumps all the other groups down accordingly. So we don't even need to, again, we don't even need to dummy code it ourselves. If the variable is coded as 1 and 2, process will recognize that and change it to 0 and 1. Here's how we'd write up our results if we did it in process. You'll notice they're going to look pretty much the same as they did 2 weeks ago. A regression using sex, signature size, and their interaction to predict narcissism score revealed a significant interaction. Here's your F-change test. And then we see that we ran separate simple regressions for men and women, which found a significant relationship between signature size and narcissism for women, but no such relationship for men. Let's also quickly redo the maximizers example that you did for homework for practice a few weeks ago. Does the effect of maximizing on well-being depend on society? So here we have a situation where our moderator has 3 categories now, US, China, and Europe. We want to know if the relationship between maximizing and well-being differs between those 3 societies. So we're going to go into process. We're going to set this up as we normally would. So our X variable is maximizing score, our Y variable, our outcome, is well-being, and our moderator variable, US, China, or Europe, is going to be in here as W. Now, as I mentioned earlier, because our moderator has more than 2 categories, we have to let process know that our moderator has more than 2 categories. So we're going to go into the multi-categorical menu and we're going to check the box telling process that variable W is multi-categorical. As we normally would, we're also going to go into the options menu, ask for code to get a graph, and ask for mean centering. All right, first, in our output, process gives us a little key that tells us how the variable was dummy coded. So what was originally coded as society 1 is now our control group. It has zeros for dummy variable 1 and dummy variable 2, and it shows us how society 2 and society 3 are coded. To fully make sense of this, we of course need to know what society 1, 2, and 3 are, so we can get that from the value labels menu. So in our original data file, US was coded as 1, China was coded as 2, Europe was coded as 3. This box over here tells us how process has done the dummy coding for us. So dummy variable 1 is coded like this. Dummy variable 2 is coded like this. So what it's done is it's taken the lowest group, USA, and it's made that our control group by giving the USA zeros for both dummy variable 1 and dummy variable 2. China gets a 1 on dummy variable 1 and a 0 on dummy variable 2, and Europe gets the opposite. Europe has a 0 on dummy 1 and a 1 on dummy 2. In other words, dummy variable 1 is comparing the US against China. Dummy variable 2 is comparing the US against Europe. So this key is really handy in making sure that we know what the dummy variables actually mean, what they're telling us. Now we can go ahead and look at our output. So in this table, which we're used to calling the coefficients table, we have our alpha, we have maximization score, we have dummy variable 1 and dummy variable 2, and then we also have our 2 interaction terms. Because remember that when we have 2 dummy variables, we need an interaction term for each of the dummy variables. Now, if we skip down to the bottom and we look at the F-change test, remember that this test tells us whether adding the interaction improved the model or not. So in this case, what it's telling us is if we had a hierarchical model where block 1 just had these 3 things, just had maximization score and the 2 dummy variables, and then we added the 2 interaction terms in block 2, the results of this test down here tell us that adding those two interaction terms significantly improved the model. The model was better with the two interaction terms than it was without them. Now, in this situation, what we need to do, since we have two interaction terms, is we have to look at them individually and see, did they both improve the model or did only one of them improve the model? So we actually have to jump back up here and we see that interaction term 1 was significant. And remember that dummy variable 1 compares China and the US. So what this is telling us is that the relationship between maximizing and well-being is different in the US than it is in China. The second interaction term, however, is not significant. And remember that the second interaction term is the one that uses dummy 2. And dummy 2 was comparing the US against Europe. So the fact that this interaction term was not significant is telling us that the relationship between maximizing and well-being is the same in Europe and in China. In Europe and in the United States. There's no difference, but it doesn't matter whether you're in Europe or the US, the relationship between those two things is the same. So we still have to make sense of the first interaction term that compares the US against China. So if we scroll down, we will get those outputs again. Society 1, remember, is the United States, Society 2 is China, and Society 3 is Europe. If we go through these rows one at a time, we see first that the relationship between maximizing and well-being was significant in the United States, but it was not significant in China, and it was significant in Europe. So as we just saw from those two interaction terms, this relationship is different in the US compared to China, but it's not different in the US compared to Europe. This might make even more sense if we use that syntax to make a graph. So we'll copy and paste that syntax and get a graph that looks like this. I'll add the lines for you and even the flags while we're at it. And what we see here is that in the United States, the dark blue line, and Europe, the light blue line, in both of those societies, there is a negative relationship between maximizing and well-being. But in China, the red line is flat. So we do not have a relationship between maximizing and well-being in China. So again, different process. It was a lot faster and easier to do it this way, but we ultimately got the same result. We found that there is a negative relationship between maximizing and well-being, but only in US and Europe. No such relationship exists in China. Point of your next exam, so when you feel ready to take the exam, you can shoot me an email and I will send it to you with further instructions. Just to clarify, the exam will cover the content of the multiple regression 1, 2, and 3 lectures. So it will cover multiple regression, hierarchical regression, and using process to test for interactions, both between continuous and categorical variables and between two continuous variables. But in either case, we now know that we can use process to make our lives much, much easier in terms of testing those fairly complicated things. So that's it for this lecture. We are now up to the